It was cool. Okay, so fermentation. Also a really easy reaction to basically identify because it's always going to have yeast as a catalyst. Fermentation is a chemical process in which yeast cells secrete the enzyme called zymase and breaks down the six carbon chain of sugars into what are the products of fermentation? Not water, but CO2 and alcohol. Yep, this is going to give you CO2 and alcohol. So when we produce alcohol, you have to start with some type of sugar. Um, this sugar can come from a variety of sources. It can come from corn, grapes, in the production of, you know, drinking alcohol. A lot of times people use a plant called hops. Um, but the point is that you basically just have to have a sugar containing plant or fruit. All right, when farmers are being paid for corn, that corn is then used because corn has a high sugar content, and yeast is added, and you produce from this alcohol and carbon dioxide gas. Now, this reaction is used a lot more than what you might even think because every time you bake bread, this is what you're doing. Think about how many recipes call for sugar and then yeast. So, what is the actual? Where does the alcohol go? Because you're not really consuming alcohol; it evaporates. How many people love the smell of fresh baking bread? You walk in, you're like, "Oh, that smells good." Guess what you're actually smelling? Alcohol. That is what as that alcohol evaporates, you're getting that sweet smell. That is the alcohol smell. And then a lot of times people forget it is the carbon dioxide that plays the important role of helping the what to happen? The bread to rise. So as the bread rises, it's because you're producing this CO2 gas, also the alcohol here. Um, some of this actually is gas phase is actually more appropriate. That is also probably also aiding in the rising of the bread, but the CO2 in particular helps the bread to rise and giving you the kind of light, fluffy texture rather than the hard, dense, more texture of like a biscuit. But that's what you're doing. Really easy reaction to identify. If it has yeast and you're producing CO2 and alcohol, you know it's fermentation. Next one, called polymerization. We did it in lab. Organic compounds made up of chains of smaller units covalently bonded together are called polymers. And the formation of polymers is called, obviously, polymerization. And the individual unit of a polymer is called a monomer. And there are lots of different ways to show this, but really the classic way that you're going to do this is actually, let me see if I still have it on the board here. Took it down. Is you're going to start out with something that looks like this, N, and then it'll say something like C2H4, and then it kind of changes. And what happens here is this has a double bond. It'll change to giving you something like this, where it'll say like CH2 CH2 parentheses N, and it might even have lines going off it like this. So what do they mean by this expression? You're starting out with a given number of a small unit. The small unit in this case looks like this. Okay, that's your small unit. And when you polymerize something, generally what you're doing is you're breaking the double bond to form a chain now of that repeating unit. In this case, it's the CH2 to CH2 that's the repeating unit, and you can just make a really, really large chain out of that. So that is called polymerization. Uses of polymers are incredible. Anytime you're dealing with rubber, you're dealing with a polymer. A lot of plastics are made from polymers, but here's a couple of big ones. Nylon, styrofoam, polystyrene are all examples of synthetic polymers. So the next time you're wearing polyester, you're wearing a polymer. So you've joined small little units into a large one. Now there are a few that are naturally occurring. Proteins are naturally occurring polymers, and also starches and cellulose. These are a few that are naturally occurring polymers. When we talk about starches in particular, if you take two glucose molecules and add them together, you will form what? Two glucoses give you, was that? Yes, kind of. It's a more complex sugar called sucrose, C12H22O11 plus water. So this is what happens if you take two simple sugars and make a complex sugar. You're taking two monomers and joining them to make a polymer. All right? And so when your body does the opposite. Let's say that you need a lot of energy real quick. What is a great thing to eat? In the form of a fruit. All right? So if you've ever gone to a basketball game, they used to do this when I was in school, they would give us oranges at halftime. Have you ever had that happen? It used to be kind of a tradition in basketball, if you played basketball, that you get oranges. Sometimes in older movies for basketball, you see like oranges passed out during halftime. Fruits are made up of simple sugars, and those are the quickest that your body can use and convert into energy. Now, if you have something like bread, which has a complex sugar, your body has to break it down into the glucose before it can use it. So that's why a fruit or drinking like juice is a really good way to get energy quickly. We can skip this because we've already hit it. Let's jump down to, let me actually skip this as well.
These aren't going to be on the test, right? The ones that you say skip.
They won't be on the test in the sense that you do. What you know is what is given. So you're good with going with what you know. Over the last page, benzene series. The most important cyclic series is called the benzene series. The general formula is C6H6. And molecules that have this general formula are classified as aromatics. So benzene is this interesting looking molecule that has 6 carbons, and then it has a hydrogen coming off of each carbon, and you're going to notice the double bond pattern within a benzene molecule is shown in an alternating sequence of double, single, double, single. Now, what's interesting about this molecule is that you can actually draw it, and I'm going to do the shorthand form here. You can draw it with the double bonds expressed in this position, but it's identical to draw it with the double bonds expressed in this position as well. As long as they are going double, single, it doesn't matter where you start. And what this means is it gives you what is called a resonance structure. And a resonance structure means the actual molecule is halfway in between both of those. So that's why you can use either form to represent benzene. The actual molecule is in between both of those. So the actual structure is what we call a hybrid between those two structures, so either one works to represent them. Each of the bond lengths of benzene are longer than a single bond. Longer than double, but shorter than a single. The other way to draw benzene is to simply draw the six-membered ring with a circle in it. And if you have, like an example, a CH3 group coming off this, we call this, actually we don't even do the name. It's called methylbenzane or something called toluene. It's used a lot in a whole different range of organic molecules involve carbon groups attached to a benzene. Sophia? No problem. Okay. I think that's where I want to stop. What I want to do now is have you take a look at the homework that we had over the weekend. And I want to review the 6 different types of organic reactions. Real quick, I don't want to spend a lot of time on the ones we just did, but we started here the other day talking about combustion. And the keys to recognizing these is to get the clue right. What is a dead giveaway that you're dealing with combustion? O2. All right, when you have a free O2 molecule, that is combustion, and you know you're going to get what 2 products? CO2 and water. Very good. This one down here is one that gets people. The next 2, what are called substitution and addition reactions, these are the ones that I think are the most confused type of organic reaction for people, but there's an easy way to remember them. A substitution reaction involves a substitution of a halide into a carbon chain. And the clue here we said was use the phrase single substitution. And what that means is you will only have a substitution reaction when you have single bonds of the hydrocarbon. So if you have all single bonds and you're adding a halogen, you end up substituting one of the halogens in, and then you get HCl as a byproduct. Single substitution. Now the reason people confuse these with addition reactions is look how similar they look. You've got Cl2 still being added, but this time you have a double bond. When you have an addition reaction, you break the double bond and add both the chlorines right into the carbon chain. So this is an addition reaction because you have a double bond present with the halide. The substitution reaction has all single bonds in what you're trying to add the halide to. So single substitution. Then we talked about esterification. And esterification is another one that people oftentimes confuse, but it's easy if you remember, you form an ester, the acetyl bond O-O, when you have an alcohol and an acid. So anytime you have an alcohol and an acid, you form an ester. Zoe? Sure. So alcohol plus acid gives you an ester. How do we know we're dealing with soap? Base. That's right. You're going to have a base present. When you're dealing with soap, you've got a base, and we call that saponification.
Is it gonna be like give us like an information and then say what type of
Correct. Yep. Fermentation. What's the giveaways? This is an easy one. Yeast, CO2, alcohol. That one hardly anyone misses. All right, that's a pretty easy one to pick out. And polymerization, the key here is that you're usually seeing this N. Thanks. You're seeing something like this, where you have an N in parentheses with a monomer, and then you have this chain where the N dropped down here, and you've gone from double to single bonds. You've taken small units and you stuck them together to form the polymer. Sophia. That's exactly what it is. It's just simply saying you might have 10 of these, or you could have 50 of them.
Are they the same on both sides?
Yes, they are. So if this is 10, then you're going to have the same over here. Yep. But oftentimes when they ask you this on the Regents exam, they leave that as a variable. So if you see something like with N, that's telling you that you're dealing with a polymerization. Okay. Yes. Is it? I just don't want you to miss the answer to the homework, but yes. Is this like a nurse extended visit or a nurse short visit? Okay. Well, if it's a long visit, just try to get it from Sophia, and that'll be fine. Okay, what I want to do is I want to try to go through this, and then I want to give you some clues. So let me give you an example. For number one, I look at this, and as soon as I see a halide, all right, we've got Br2, a group 17 molecule, we've got a halide there. As soon as I see that halide, I'm thinking to myself, this is what two reactions? Yep, it's organic one. Sophia, you look like you have a blank look in your head.
Substitution and addition.
This was the homework. Did you do the wrong one? Organic reactions, number one. That's right. So as soon as I see this halogen, you need to think to yourself that's addition or it's substitution. Now you might have to draw out the first molecule. And when you draw out CH4, you'll notice what type of bonds? All single. So that immediately tells you single substitution, and that's why that is substitution. Come down to number 3. Notice now I've got another diatomic, all right? So in this case, it's a hydrogen, not a Cl2. So you can have this with a diatomic. But I've got a diatomic, and then I've got this molecule, CH2CH2. And I want you to notice that the only way to draw this is to draw it correctly with a double bond. And so that's why in number 3, that immediately is classified as an addition reaction. That's an addition. Okay, let's go over the answers. Yep, see how there's only one product instead of 2? Up here you get CH3Br plus HBr. Here you added both hydrogens into breaking that double bond, and so you added, there's no other, there's just a single product. Yep. Okay, I'm going to just give you the answers, then we'll go over them. 1 is C, 2 is C, 3 is C, 4 is B, 5 is C, 6 is C, 7 is A, 8 is B, 9 is A, 10 is A. Eleven is B, 12 is C, 13 is C, 14 is D, 15 is A, 16 is A.
What'd you say for 13?
13 is C. Okay, let's go back to 1 through 10. Fire away, and the good news about these is if you can learn the clues, they're not as hard as what they seem. All right, so we'll see if we can show you the clues here if you get stuck with one. Go ahead.
I need help with number 4.
Number 4, which is a substitution reaction. So obviously, the only one actually that I can immediately eliminate by just a quick scan is letter C. Why can I eliminate C? That would be combustion. Okay? So I'm looking for something that has either an H2 or a diatomic. Now the way that I need to do this is I have to figure out which one of these first hydrocarbons has a single bond. All right? But there's another way as well. And actually it's easier. That's exactly what I was going. Good job, Madison. Get rid of the ones that have one product. A and D. See how those have one product? When you have a substitution, you're going to have 2 products always given. And you will notice C4H10, that fits the formula of an alkane with single bonds. The formula, remember, is C to the N, H to the 2N plus 2.
Okay.
So 4 plus 2, 2 times 4 is 8, plus 2 is 10. So C4H10, you know that is a single bonded compound. But Madison's idea, I think, is even easier. Look for the one that has 2 products given. Sophia. 5. Which compound undergoes addition? The only way we can figure this one out, Sophia, is figure out which one is unsaturated, meaning we need one with a double bond. So we need something with the formula C to the N, H to the 2N, or C to the N, H to the 2N minus 2. Both of those, this represents an alkene, this represents an alkyne. The only one that is going to be completely unsaturated is this guy right here. You can see how it has twice the number of hydrogens as carbons, and that's going to have a double bond. It'll look like this. So that's the only one that will undergo addition because it has the double bond.
So they undergo addition if they have double bonds.
Correct. So think single substitution, but addition, I don't have a good phrase for it, but
Right.
addition, double bond. Yep. Okay, another one.
8.
Number 8. Which type of reaction is represented below? Now, this is a little bit tricky, but there's a good clue right there. You've got CO, and that is why it is incomplete combustion. You probably were thinking, oh, that's got to be combustion because it has O2, but there's obviously just straight combustion wasn't an answer. It's incomplete because it didn't fully burn. It had some CO produced. Another one? To the back. Number 11. Which type of reaction can an unsaturated hydrocarbon become saturated? Okay, if you think of what happens with an addition, think about like something like this. C2H2, and if you add hydrogen to it, what you're going to do is you're going to completely break the double bond, and you're going to include both hydrogens within the molecule. So you're making something that starts off unsaturated because it has the double bond, become saturated. So you want to do an addition reaction to do that. If it says odor, where at? Yeah. Very good. Esters are responsible for pleasant odors, things like fruits, and a lot of scents are made of esters. So that's where that comes in. But the other key, if you didn't pick up on the odor part, alcohols plus acids produce esters. Alcohol and acids produce ester. Sure can. Which type is represented below? As soon as I look down here, can someone show Kaylee the clue? Double bond. So as soon as I see that double bond with hydrogen or a halide, that's what's making me think this is addition. Did you put substitution?
Yeah.
Yep. And that's the most common mistake because they look very similar, but remember, single substitution, that would have to have all single bonds to be substitution, and you'd have 2 products. In this case, you only have the 1 product, so it doesn't.
This is like finally starting to click.
Good.
For esterification and
Yes.
esterification, alcohol's like in the reactive part.
Mm-hmm. Absolutely. That's exactly right. Esterification, you use the alcohol to produce the ester. fermentation, think of it, when people do fermentation, they are trying to get the alcohol, all right? Whether they're going to burn it, drink it, whatever, they're trying to get the alcohol. Anything else there? Okay, what I'd like you to do is, there's a second example sheet that I put online.